So today I want to talk about BGP and data center fabrics because that's what everyone is doing, right? Everyone is doing BGP on their data center fabrics today. Everybody's moving in that direction. This is what everyone seems to be doing. But I'm going to tell you that I work for a hyperscaler, and the hyperscalers are moving away from BGP on their data center fabric. So I want to tell you why and what we're just a little bit about what most of the hyperscalers I know are doing. So if you look at the past, Facebook went to BGP, right, when Petr Lupkov came over there, and John and some other folks wrote this draft in the IETF, and Ivan Pepignac. Oh, by the way, Peter, I wanted to ask you, that original edition, where'd you go, Peter? He's out in the back someplace. I was going to ask him if that original edition he bought when it was new. we old folks get to make fun of each other. So, and by the way, yes, I did do vampire taps, and yes, I am probably, how many people have deployed ArcNet? 1, 2, 3, more than I thought. I actually deployed ArcNet in Morrisville, New Jersey, because there was a building that we were using, that they were using as a lawyer's office, and it has asbestos in the walls with Cat 1 cabling. And there was no way to do anything other than ArcNet over Cat 1 cabling and make it work. Anyway, so if you hear people and you talk to any operator today, and they say, what are you going to use on your data center fabric? They say, you're using BGP. Why are you using BGP? And they say, because of draft Lupkov. Well, what's really funny is Petr is not doing BGP on his fabric any longer either. So Microsoft is BGP today. You might have heard that Microsoft bought LinkedIn, so I kind of know a little bit about their network now. I'm not sure if that's a good thing or a bad thing. I tend to leave their jaws dropped on the ground when I make my rather weird pronouncements when I go to Microsoft. But anyway, they're running BGP today. LinkedIn is running BGP today. LOR1, which is our newest, and Singapore data centers are both running BGP. Our Oregon and Singapore data centers both run BGP today. Just to give you a sense of scale, the Oregon data center is 300K servers on a single fabric. That's typically the scale LinkedIn builds. Singapore is a bit smaller than that, but they're both BGP. Google, of course, we all know started out using BGP, right? So why were people using BGP? They were using it because this is an old document from Juniper online. Someone I know actually wrote, I think it's kind of entertaining to use this because I know this person, Doug Hanks, that you look at these requirements and they had things like prefix distribution and packet prefix filtering and traffic engineering and traffic tagging and multi-vendor stability, and all these things were really important. And if you get on the list, it looks like, according to this little chart, that BGP is the way to go. And by the way, I didn't bring my cell phone up here, so I have no idea how much time I have. So someone will have to scream at me when I get close. Anyway, I can either do this fast or I can do this slow. My record is 96 slides in 15 minutes. And that's because I was taking over a speaker slot, and all I had was network diagrams, and I had no idea what the network diagrams were supposed to be saying. There was no text. Anyway, so they had all of these requirements, right? And then if you go to draft Lupkov, which is the one I was just talking about, you can see down here at the bottom all these really cool requirements: Rec 1, Rec 2, Rec 3, Rec 4, select a topology that can be scaled horizontally by adding more links, and network devices of the same type without requiring network upgrades to the network elements themselves. By the way, this is something else hyperscalers do that you probably don't. There are no chassis boxes in most hyperscaler networks. Most hyperscaler networks are 1RU boxes. We disaggregate, we externalize the fabric for very specific reasons. What is the number one killer of microservices architected applications? It's not bandwidth, it's delay. And the number 2 killer is jitter. And so if I disaggregate my fabric and I externalize it and I don't use any type of chassis boxes, it makes it a lot easier for me to work on figuring out where delay and jitter is and controlling it. Anyway, so you can see all these things that are here in draft Lupkov. But now let's look at what's going on right now. Facebook is actually working on and deploying OpenR. Now they're using BGP as well, but they are using OpenR in some of their data center. Microsoft is rather stodgy. They've gone from BGP to BGP. It's a beautiful thing. LinkedIn, we're currently on BGP. We're moving to something called OpenFabric. We'll probably use BGP in the core, and we might use BGP as a southbound interface in some network sections, but we're moving towards OpenFabric. And then Google, it used to use BGP, and they now use something called FirePath and or other variants of FirePath, which was the original thing. And then there's all this activity in the IETF over things like Rift and OpenFabric, and Tony Lee has a draft out now. I was quite amazed. I saw Tony Lee at the IETF last 2 times. I've seen him out there. And so the question is, what changed? Why are we moving away from BGP as our data center fabric protocol? There are a number of reasons. Number one is SDN. And what SDN did, even though we don't really deploy OpenFabric OpenFlow in many places today, not many people use OpenFlow for much of anything. Google uses it for some things and things like this. But is it taught us to rethink the way we manage our policy and our data center fabric. Used to, what we would do, if you go back to that slide before, one of the requirements was I wanted to be able to put my policy in the fabric. I wanted to be able to have my routing protocol, carry my filters, carry all of my traffic engineering stuff and everything like that. What's happening is with the advent of SDN concepts, I'm actually moving away from this idea of pushing my policies inside my routing protocol. What I want my routing protocol to do now, my distributed routing protocol to do now, is I want it to do nothing but discover topology and reachability. And I want it to do really fast and do it very simply, the simplest way I possibly can. So complexity of mixing policy and reachability has really hit home. In a hyperscale environment, if I'm really holding up 300,000 servers to 1.6 million servers, I cannot afford complexity on the fabric. I want my fabric to be cheap, dumb, fast. I don't want it to do anything for me. I want the fabric to be totally dumb. So IP top of rack to top of rack, and that's all it does. Our perception of configuration is changing. Everyone is into DevOps. How many of you are deploying DevOps today? I bet you everybody raises their hands, because if you don't, you'll be embarrassed by saying you're not doing DevOps today, right? So really, again, when I get up to 10 case routers in a fabric, I want to move away from the concept of DevOps and move towards the concept of autonomic. I don't want to have any configuration on the box. And this, by the way, is where my Microsoft counterparts kind of fall off the edge of the chair when I say this. I actually want to be able to rack and stack a box, and when you do show run on the box, there is no configuration. There should be no configuration on a switch in any data center fabric. None. Zilch, nothing, zip. Should be no configuration. So this is the difference between zero-touch provisioning and DevOps versus something I call autonomic. So this leads to this concept of a layered control plane, right? So what I do is I have a controller that wants to have a full view of the network, right? What can I do to get a full view of the network? I can do a lot of different things. I can use BGP, and I can use BGP-LS, and I can grab everything and drag it into the controller. Beautiful. Now I have point-to-point links to all of my top-of-rack switches and all of my routers in the entire network. That's kind of ugly. I have all sorts of stuff going on there that I don't like. If I have an LSDB, if I have a link state database, if I have a link state protocol in that fabric, I can actually do snapshots of the LSDB. And all I have to do is touch a couple of devices on the edge, and I have a full topology view, and I know exactly what's going on in my network. So I can actually take snapshots of the LSDB, and I can push it into a TSDB, and I can actually, time series database, I'm sorry, I use lots of little things here anyway, a time series database, and then I can call Rachel, and Rachel can figure out how to find the anomalies. She's going to tell me she hates the word anomaly. In about 2 seconds, she's going to smack me upside the head. Anyway, and she can help us find the anomalies in the LSDB over the time series database and tell me what's going on in my network. My overlay, on the other hand, is policy only. I want my overlay to be doing nothing but my policy, traffic engineering, filtering, distributed firewall, things like this. So by splitting my policy from my reachability and my topology, which you may have heard me talk about before in some other presentation, I'm really helping myself do a lot simpler type of stuff. So now let's go back to that chart and think about this, right? My requirement is prefix distribution. Sure, OSPF does that. Path filtering, it's limited, right? This is what we had before. OSPF and ISIS do limited path filtering. Traffic engineering is very limited in OSPF, ISIS. Tagging is basic. Multi-vendor is still, this is the original chart now. If I go down to the bottom, I can see that in reality, I've taken the 3 things that were limited in OSPF and ISIS, and I'm handing them to the SDN overlay. At the same time, I'm getting better telemetry off my fabric, and I can make BGP do what I want it to do through auto configuration. and full view of topology, but it's a lot more work than it is if I'm using ISIS or OSPF. And no, we're not using OSPF. So what do I need to do to make BGP? Donnie Savage, who was an Edge RP coder, said that he wouldn't allow anybody to use OSPF in their network because he wouldn't let them use 4-letter protocols. Sorry. See, my jokes just get worse. So anyway, ISIS at least has a dash in it. So what do I need to do to make BGP work? I need to auto-compute my router ID and all of my AS numbers. And then once I've auto-computed them, I need to be able to tell my neighbor what those things are, right? So I got to have all this type of stuff going on in there. So I need to peer on link locals, auto-discover my local peers through some secondary protocol. There's some stuff around LLDP and stuff like that to do this. Use something like BGP-LS. Peer with anybody who tries to tell me that's not a security issue in BGP. Anyway, peer with something like BGP-LS to gather a topology at the controller, but I still need to configure my remote peers policies. I need to carry my policy in my distributed protocol. There's all these things that go on that you have to do to make BGP work. Now again, why am I doing this? Why am I using BGP in my fabric? One, because BGP gives me policy in my distributed control plane. But again, I'm trying to separate these two things in order to reduce the complexity of my control plane. BGP is well known and widely implemented, right? Everybody here knows BGP, I guess. I would guess everybody here knows BGP. So this is valid if you're using vendors. But when you move in a data center more towards an open source model, then all of a sudden the whole argument about BGP being widely implemented and stable kind of goes away because you're running your own software. So I know this doesn't apply to a lot of other people, a lot of smaller players in the networking space. And I think by the way, I think disaggregation and buying software and hardware separately are going to filter down into the larger operators that are not hyperscale at some point. But anyway, so this all changes the game. BGP scales better. Well, let's think about this for a minute. What are my scaling issues? BGP can handle more prefixes. So yes, BGP handles the best implementation of BGP I've ever seen. We threw 100 million prefixes at it, and it didn't break a sweat. That was, by the way, Ericsson and IPOS, and you can't buy it anymore, so I can actually say that in public now. But Ericsson IPOS, we used to throw 100 million prefixes at BGP, and the processor util would take a short bump, and then it would go back to normal, and everything was happy. Very good, very good BGP implementation. But how many of you are running 100 million routes in your data center fabric? If you are, I think you need to hire me as a consultant because you're doing it wrong. I'll be glad to take your $150,000 or $200,000 or whatever it is and help you fix that problem. But there are mitigating factors like modern processors. Back in the day, when OSPF was designed, we were running on 8-bit, 6-bit processors and 8-bit processors, and we were running very, very slow 8-bit and 6-bit processors. We've now learned how to optimize SPF. It's very, very fast. We know how to do partial SPF and incremental SPF, although incremental SPF people don't like. It's very, very complex. But we know how to do partials. So in reality, we can get to 250 to 300,000 routes in a link state protocol in ISIS. And it's not really that hard to do. And 10K nodes is not really that hard to do. Now, if Tony P were here, he would come up and tell me I'm insane. But I don't think those are beyond the reality of what you can do in a link state protocol. So BGP can handle more routers in a single network. Sure, but this comes down to flooding, right? What's the problem with link state protocols is my flooding speed. So now let's ask the question, why am I using ISIS to do this? Almost all the current proposals are modified versions of ISIS. Why? Because it's easier to modify than OSPF. Although OSPF has now gotten to the point with the newer drafts, they're doing TLVs, so it makes it easier to modify. Flooding domains are less entangled. OSPF entangles flooding domains in the LSA type. ISIS does not. Therefore, it's easier for me to mess around with this type of stuff. Packet format is TLV based. It's easier to do partial SPF and incremental SPF in ISIS from a coding perspective. And the other really cool thing about ISIS is I don't even need IP addresses on my fabric. It's layer 2. It's its own protocol. So it just runs on top of layer 2. I don't need all this stuff. And Nick's back there shaking his head. That's okay. Yeah. So So let's talk about the flooding problem very specifically. In this network, this is a simple five-area class, folded class, I should say to be proper. This is a five-area folded class that is 4 wide. So if I look at it right, each IS in this network will receive at least 4 and potentially more than 8 copies of each modified LSP. Why? Just because of the timing and the way things flood. So there are multiple ways to solve this problem. For instance, OpenFabric solves this problem by doing neighbor's neighbor calculations. And this is something I learned how to do, or we patented it when I was at Cisco when we were doing mobile ad hoc network work. So the idea is that I will actually, from this router, I will compute, say from 4A, I will compute that all of my neighbors at 3 have the same set of neighbors at 2. So 3A has exactly the same neighbors as 3B, has exactly the same neighbors as 3C. So what I do is I say, you know what, I really don't need to flood to everybody here. I don't need them all to reflood. So what I'm going to do is I'm going to send my flood to 3A, and I'm going to tell 3A to reflood it to all of his neighbors, but I'm going to tell 3B through 3E not to reflood it. And this is actually really, really simple to do with linked local flooding that's already built into most ISIS implementations. You just have to figure out how to do it in the code, so it's not very hard to do. So you use RFC 7356, and you do linked local flooding. So this is what I call the forward optimization. What I do is I'm trying to optimize the flooding of a LSP from the source towards the rest of the fabric. Then on the way back, all I have to do is when I compute my SPF, I already have an SPF towards every destination. All I do is I say, does this LSP, was it sent to me by someone who is on my shortest path or on a shortest path using ECMP back to the source of the change? If that is true, I simply don't reflood it or I don't accept it. So that allows me to back off all of the backwards or the back scatter. So this allows me to get to the point where this is, by the way, coded, and this is working. It's not publicly available yet. Well, it is if you know the right GitHub repo to go to. This will be released as part of free-range routing, but it's in a kind of quasi-private hidden GitHub repo right now while we're playing with it and trying to get it all to work. But anyway, this is working, and we can actually tune. If I only want to have one reflooder, every IS in the fabric gets exactly 1 copy of every LSP change, regardless of how large the fabric is. So this really solves the entire flooding issue in ISIS. So there's another way of doing it. It's something like what FirePath or Tony Lee's draft does, which is you take all of your LSPs, you send them to an LSP server, and he refloods them back out. Then you calculate SPF locally, and everything is good. You can read draft Lee dynamic flooding, which is a very, very long version of the same thing. Or if you read Jupiter Rising and you read between the lines in Jupiter Rising, the paper by Google, that's exactly how FirePath is doing as well. So scaling problem, right? Route count is not a big issue. Again, there are solutions in this space. I can do incremental. Node count comes down to flooding. So what else do we need? I need auto configuration bits. For ISIS, obviously I can use my layer 2 Ethernet address, thanks to Peter, to calculate a local ISID. So that's very easy for me. I can do link local IPv6 through Slack. I actually don't even need my link local addresses because I'm layer 2. So all of this just works. Loopback for management, everything else. Local label pool for traffic engineering can be calculated off my MAC address. What is really cool about OpenFabric is, and by the way, this algorithm's wrong. This is what's in the draft right now, and it doesn't work. It's coded, and it doesn't work. There's a new version that's being coded up, and I'll change the draft whenever I get around to making sure that the new version is coded and works. Anyway, is I can actually calculate whether I am a top-of-rack switch or whether I'm a spine or a super spine. So if I'm a top-of-rack switch and I know I'm a top-of-rack switch, I can go reach out to a server and grab a DHCP pool. I don't need local configuration because I know where I am on the fabric. So this brings me down to the point where I can tell my SRE, a certain switch is broken, go over there, replace it, rack it, plug the cables in, and boom, it works. I don't do any configuration. All I got to do is make sure I have RPM to the right packages onto the switch itself. This is advertised in a tier TLV. There's another way of doing this, which is done in draft Shen ISIS spine leaf. Naming and Les Ginsberg, Naming Shin and Les Ginsberg are working on this out of Cisco. And what they're basically doing is saying, you mark all your T0s, you mark all your top-of-rack switches, and then you actually advertise what your tier number is up. And if you're connected to top-of-racks T0s, then you automatically figure you must be a T1. So you just advertise up, and everybody figures out what they're connected to, what their tier number is based on what they're connected. So policy overlays, what can we do here? Well, there's lots of different policy overlays. PSAP, I2RS, which seems to be dead at this point, unfortunately, because I really, really like I2RS. The working group has gone to sleep. Very, very few people are implementing it. I'm trying to get an implementation in free-range routing going, but I really like I2RS, but it seems to be falling off the edge of the earth. And BGP is a southbound. Of course, I can always use BGP LS, or I can always use BGP SRTE to send segment routing label stacks to my top-of-rack switches, or even down to the application, and let the application impose a segment routing label stack on top of the packets that it's sending. And this allows me to engineer traffic over the fabric without having to do constrained SPF or anything else on my routers and switches, or my routers inside the data center. By the way, everybody that I know of in this space is moving to segment routing. We always say it's what MPLS TE should have been in the first place. So what we think is, one thing we have talked about doing is using Kafka, which is our internal pub subsystem, and pushing gRPC or something like that in Kafka to all of the routers to push policy out. We don't know if Kafka is going to scale to that point. We're working with them on that type of thing right now. So summary, BGP is a good data center fabric protocol. Don't feel bad if you are using BGP as your data center fabric protocol, because most of you probably are. For some specific situations, right? If you want your policy mingled with your reachability, if you like using communities for QoS type stuff and things like this, traffic engineering, for carrying labels, it is a really good protocol to use. Little or no visibility into the topology. You can play with this. You can use BGP-LS. Strong multi-vendor support is absolutely true. Again, if you're disaggregating, then the game kind of changes here. Single source of truth with strong DevOps operations. So if you have the concept of having a single source of truth database with strong DevOps, then BGP is a good solution because you're using a single source of truth to actually configure everything. If you're trying to go towards a model of I have 10K switches in each data center fabric or more, and I simply don't want to configure them any longer, I just want them to have no configuration, then BGP becomes more problematic. So each of these points is being challenged. So we're arguing that policy should be separated from reachability and topology. We have strong requirements for topology visibility for controller-based SDN-ish type things. And of course, we want to minimize and configuration and do autonomic operation. So link state protocols fit these requirements better. So that is why you are going to see a lot more activity in the space of doing link state in data center fabrics. And if you have questions about any of the drafts or anything that you'd like to know about some of the stuff that's going on, feel free to email me. You can find me pretty easily. I'm not going to tell you my email address because it's so darn easy to find.